In this video, we are going to see the implementation of queue in C language. So to start with, we will see the insertion operation. As you can remember, the queue has got two ends, the front end and the rear end. So insertion is always done from the rear end and deletion is always done from the front end. To point these two ends, we have got two specific pointers called front pointer and rear pointer. Front pointer will point to the front end and the rear pointer will always point to the rear end respectively. So in the following diagram, you can see that there is a scenario where in which this is a queue and the rear pointer is pointing to the rear end and the front pointer is pointing to the front end. So how do you do the insertion? That we are going to see now in a graphical illustration. So this is the empty queue. Where are the pointers now? As the queue is empty, the pointers front and rear are grounded. You can recall the point of grounding in stack, so which we have discussed in detail earlier. Now you see that I want to insert element 10 into the queue. Now the pointers are grounded. When I increment the rear pointer, why rear pointer here? Because insertion is always from the rear end. So R was grounded, so R was incremented. The value of R was -1. -1 plus 1 is 0. So R is pointing to the 0th location or 0th index and 10 is getting inserted. I want to insert 20 now. So the rear pointer is now incremented and it is pointing 30, 40, 50, 60. Similarly, we'll insert 70 and now you can see that the front pointer is pointing to the element which was inserted first and the rear pointer is pointing to the element which is inserted at the last. Now what is the code to insert? You see that the rear pointer is incremented by 1, then the value is inserted into the queue. So have we left out any conditions? Of course we have left out. The first thing that we have forgotten is that queue is also finite, so we'll have to check whether the queue is full or not, right? That is one. And the second is, if the element is inserted into the queue for the first time, you can remember that both front and rear pointers were grounded, and it becomes our responsibility or obligation to bring the front pointer also to the same position where the rear pointer is pointing. So these are the two things that we have to take care of. Now I have got the code with conditions. So if rear is less than max -1, because we are starting with 0 index, that was why it becomes max -1. Then it means that there is a place in the queue to insert. So we have the same code here, right? So this is the simplest way that you can understand. How do we delete it? So delete operation is removing the elements. What is the condition to be checked? So before the element is removed from the queue, check if the queue is not empty. How do we check that? Look at the graphical illustration. Queue is full. I start removing element by element. Now from where do I remember? From the front end. I have removed 10. Now the next element which was inserted after 10 was 20. Now the front pointer is pointing. Likewise, I keep on removing. At one point you can see R is here. F will exceed R. So what happens? So F, after removing the 7th element, you can see here what I have done. So here rear is here, front after deleting 60 is pointing to 70. Now the value of both F and R are 6. I try to remove 70 now. F is equal to F plus 1. So R is 6, F becomes 7. So this is a point where in which F will override R. Now stack is empty, there are no pointers. Why did I explain you this? Because we have to see what is the condition in this. So see the C code to delete it. Now what have I written here? If front pointer value exceeds the value of the rear pointer, then I'm sorry, this is not equal to, so it is just front is greater than rear, then that is called queue is empty. Or if the front pointer is equal to -1, that is also the state to check or understand where the queue is empty. So if the queue is not empty, then increment the front pointer and delete the element. So see the code to display. The display code is very easy. Check if the front is not empty. If it is not empty, then the pointer is front to rear displayed. So applications of the queue is majorly in operating systems and computer networks. We will discuss them in detail in the coming videos. So that's the end of the video. Thank you very much.